We're on a Thursday of the third week. Just remind you of that. Tomorrow we have a tutorial, and some of the feedback you got yesterday regarding attendance to that. Be a number of people here compared to where we were before. And tomorrow we will do a quiz at the end on the material from Chapter 2, the things that we've done up to today. And so just a bit of a reminder, there were a couple concerns expressed yesterday about on the computer not being able to finish up a couple entries and so on. And so what I just did about 20 minutes ago is open that up so that you could finish that out. And so hopefully you can get access to a computer, get that finished up. Looking at the overall grades, looks pretty good. In terms of percents, looking very strong. Now that hopefully will translate into a little more positive result in terms of the quizzes. And again, a reminder, a week from today will be our first major exam in Math 20. And that'll be a 1-hour exam. And I will tell you now that I will be taking problems from the quizzes. We have 3 quizzes. And then the other comment is you need, again, a reminder. You need to have your notebook that you're doing the problems from this week and last week's second and third week signed off. It's the same ground rules we did in 10. If that material is not signed off, then you will not get credit for the quizzes or the homework, and that's the only way you can do that. So you need to arrange that with Larita. What we're still trying to do is find a little more structured situation in terms of the tutorial and additional time. A reminder for you, and I say this only from the standpoint of the quiz we just did. On the quiz, about half of you did not have a score that would be a recommending grade on that last quiz. And so I did the makeup, which was with the properties of the real number system, and that's one way of correcting that. But what that's telling you is you are not getting enough homework practice and not doing strong enough that you're surviving a quiz. That could translate into the same problem on an exam. So you really have to take that into consideration. And I would be going back and looking at those 2 quizzes plus the one we do tomorrow and make sure that you've got all those problems and that you've got them and that there's no problem. And be done with it that way, because if you don't, the chances of doing well on the exam aren't going to be there. Okay, so that's the downside. And I've mentioned to you before, one thing you have to be careful of is that as you do Math 20, it is very common to slip, sometimes as much as a grade. And so you have to do something that Lewis Carroll talked about. He's the person who wrote Alice in Wonderland, and he was a mathematician, he was a logician, and he made the statement, sometimes you have to run twice as fast just to stay in the same place. And that's a little bit of our modern day society. You run twice as fast and you don't get ahead. That's just to stay in the same place you've been. So with that, just a reminder, this weekend is a very critical weekend because next weekend the test is already done. And you need to be very sure that things are going okay. And so I've left Chapter 2 open so you can go in and do problems and practice. You need to do problems in the book. You have to be very careful that when you look at the language I'm using in the quizzes that I'm giving, that you understand what I'm asking for in those quizzes. I'm trying to be very close to what the book's asking. The thing I don't have the advantage of right now is seeing exactly what form the questions are asked in the computer and how you're responding there. So if there's any concern about that, I know Kim brought that up yesterday a bit, and it's something that we may need to discuss. I'd like to wait until the tutorial tomorrow to talk about that. Are there questions from the homework last night that we worked on that you would like to discuss? Okay? There is or isn't? If there isn't, then we go on to 2.5. And in 2.5, I'm just going to look at the exercise first. There are a lot of problems here. Let's see, they start on page 139 and go to 140 and 141. There are 96 problems. And if you really want to be able to do order of operations, it wouldn't be a bad idea. Well, maybe the first 4 skip. But even though there's a much fewer number that I assigned, it's not a bad idea on page 139 and 140 that you could do all of them. And check your answers in the odd-numbered ones. But we're talking about order of operations. Now, the only thing that is changed, rather than restricting ourselves to whole numbers, what we call the positive integers, we are allowing now the set of integers, positives and negatives. And you can anticipate that we will have same set with fractions. So it's just a kind of repetition we go through. So as I look at these, probably the things that get brought into this that we haven't done before, in problem 45 is a good illustration of what we're looking at. So let me get that brought up in the document cam so it's reasonably clear. Okay, let's go to it now. On number 45, that negative sign inside the parentheses. We talked about it yesterday. So when you see that -3, and what I'm going to do, let's leave that on the screen for a moment, Jonathan, but if I look at 45, let me just write what it's saying. We have a -3 to the second, then I have a -2 out in front, then I have a 3, then a -5, then I have a 1 plus a 4, and then I close the brackets. Let's go to the board now. There's a balance you've got to reach here between seeing a problem like this, rewriting it, and where does it become more difficult than it needs to be. Now, what we're doing right now is not what I do in practice when I see a problem like this. I'm going to do it in a different way than I'll show it, because right now I'm wanting you to understand that we trade off subtraction for what? The addition of the additive inverse. So if I were just to think of this problem, squaring it there, then I would, in terms of trying to explain to you what's happening, I would use this as an intermediate step. Now in practice, that's nearly making it more complicated than I need to. But that's what is intended. We trade off every subtraction for what? The addition of the additive inverse. Now, once I've done that, I go to the innermost parentheses, and that would be within these brackets. And so my first step would be to take this 1 plus 4 and do what? Replace it by a 5. Now, how many steps you want to write through here as you're learning what's intended is not something I want to put in concrete. But be careful that you don't try to skip too much, because you can end up making silly mistakes. So I'm going to show it this way, and then I'll go back and show you what I do once you get very comfortable with this material. Well, I'm going to rewrite this, and as I say, this is rather laborious because I'm focusing on just one thing, and that is the fact that this now is my next step, if you will. I've taken care of this parentheses and I've replaced it by a 5. So I just leave everything else as I'm going through right now, one thing at a time. In reality, I would probably take the -3, square it, and get a 9 immediately. Get it out of the way. But I am going to take it one step at a time. And now here I have 3 minus a 25, which I am going to rewrite as 3 plus -25. So what I've done is instead of writing it as a subtraction, I say I had 3 plus and then a negative 25. Now, I then go to what? This bracket. The only reason for this parentheses is to remind you that it is an integer, that that minus sign is not a subtraction symbol. Now, I'm hoping at this point you can see 3 and negative 25 and say I've got a negative 22. If you're comfortable with that, then you would have this as your next step. Now, I suspect, in terms of the intent of the problem, I probably would have been expected to do that exponent first and get that 9 right away. That would be my guess if I were looking at a complete solution provided by the text. But at this point, I'm going to now do it and say this is a 9. And here I have a negative 2 times a negative 22, which is a positive 44. And then I have my 53. Now, in order of operations, if you look at the idea of doing exponents first, we could have replaced this negative 3 to the second all the way down with a 9. But I think sometimes it's just showing one step at a time may help. Is there any question on that problem? Okay, Emily?
Looking at the third row down.
Third row down.
Yeah, over a little bit. Like, I would have instinctively said 3 plus negative 5, which is negative 2.
Okay, whoa, okay. The comment, instinctively do the addition first, but what was implied here? A multiplication, and so what is the order of operations? Multiplications and divisions first, in order given, before the addition. So your intuition would have led you down a bad path, and you would have had the error. That's why we have the statement, my dear Aunt Sally, okay, in terms of just the multiplications, divisions, additions and subtractions, and always in order given. And then we had the argument that you go ahead and group, that idea of the G, E for exponents, R for radicals, and then M, and so on, MDA, S.
The negative 3 inside the parentheses.
This negative 3 inside the parentheses,
Negative times a negative.
yes, the 2 squaring it says I have a negative 3 times a negative 3, which is a 9, and that 9's looking like an upside down E or something. Make that 9 a little more legible. So I have a 9 plus 44 at 53. Sandra.
On the second line.
Second line.
Instead of, you know, you changed the plus, negative 5, whatever.
Plus negative 5 up here. Okay.
Instead of writing out 1 plus 4, can't you do that all in just one step, all in that line?
Okay.
5?
The question being addressed is, could I have shortened it up? And I mentioned to you prior to starting this, this is not the way I would do it. This is the way I'd try to explain it. Now, if I'm going to do it, I would start combining some steps because I'm a little bit concerned of just the time it's taking. So if I were to actually do this, I would most likely, and let me just write the solution I would do in practice if I were doing it without thinking I'm order operations, I'm doing it in this section, and I want to make sure there's no confusion. I would have said, first step, a 9, then I have minus 2, and I have 3 minus 25. That would have been my first step. And I wouldn't even have changed from the minuses to plus. Then I would say, well, wait a minute, that's minus 22, so I would have said 9 minus 2 times minus 22, and I would have said that's 9 plus 44, and I'd have 53. That would be probably the way I would have done it in roughly 2 additional steps. But I'm arguing that at that point, when I got negative 25 here, and then I changed that to a negative 22, in my head I'm saying I have a 3 and a added to a negative 25, so I'm not seeing it as a subtraction. I'm seeing it as the addition of a negative 25. I just don't write it out. So the question, where's the balance between conceptual understanding and efficiency? So if I'm doing a problem in algebra, I'll be inclined to do this. And again, my reminder to you, I can't remember typically in an algebra class when we're simplifying expressions that we get things quite like this. But this is just trying to make sure you understand order of operations, and we are going well beyond what you will see ever again beyond a pre-algebra course. But if I can get it to the point where you understand all this, then no matter what garbage you see later, you can do it. So there's that balance. In the same way with, I'm going to go back to what we were talking about yesterday, and Richie made the comment about adding the same thing or subtracting from the same thing from both sides of an equation. We did a very complicated problem for this course. And my point is, I don't sit there and actually add something to both sides. I do it mentally and get the new answer. So I don't show that step when I'm doing things in practice. But when you're learning, step at a time until you get really comfortable with it, then you take your shortcuts. Don't start out of the gate with them. So I guess, Sandra, in that sense, I would expect a little bit more than what I did in my solution in the top, but maybe not this much. On a test, you're going to have to find some balance. Enough with that? Now, the other questions on here, some of them are much easier. I'm just going to sort of bounce around in this set a little bit, looking at them and getting a sense of what's involved. Because if I go to 25, let me get that first written in. I'm trying to avoid the solution written in. Okay, let's look at 25. Document cam, please, Jonathan. 25. Now, you can look at that, and I hope you can see 5 minus 3 and say, hey, it's 2, without belaboring it. Now, let me again go to the board. This is number 25, so let me write the problem. Okay, and let's leave the document cam on for a moment longer so I can get the problem written. So I have the square root of 25, and I have minus the square root of 9. And now, as I go to the board, the square root of 25 is 5, and the square root of 9 is 3. Now, you immediately get the 2, but what's intended in the book is to do what? Really, either change it here, or maybe in the preceding step, to where this was the square root of 25 plus the additive inverse of the square root of 9. The key is to understand this happens. Now, the fact that you at this point get a 2 is somewhat inconsequential. 5 minus 3 is comfortable as a subtraction without changing it to the addition of a negative. So what you write is more a matter of what you're trying to understand than getting a particular answer. And that's a balance that's, in some of these problems, very simple to see. I don't think this makes a big difference for you, and I would encourage you to do it. The more you do that, the more you're going to see subtraction as adding the inverse. Okay, let me come back center and come down to something like number 50. If I look at this one, okay. In this one, the rule of thumb, which we're calling germ days, groupings, exponents, radicals, then you have my dear Aunt Sally. You're going to do that radical first, correct? And in terms of rewriting that, and again, I'm just going to write out the problem, so we leave it on the screen a little bit longer so I can get it written out. That's minus 5. Then I have the square root of 36. I have a plus 40. I'm dividing that by a minus 5. And I'm multiplying that by a 2. And then I have, I believe that is a minus 14. Do I have the problem written correctly now? Okay, let's go to the board. This is the beginning. I mean, that's where roots, radicals first. So I'd have a minus 5 times 6, and so I would put minus 30. and I just write that out. Now, if you feel instead you'd like to write minus 5 times 6 and then wait for the next step, it's not a bad thing to do. It's just going to be a little more time consuming, and we are concerned about doing things quickly. Now, what has to be done next in my order of operations? Well, the parentheses is, you're right about parentheses, but that isn't a grouping. That's just to designate to you that I've got a negative 5. I could have, if I'd left that divide and the minus in there without the parentheses, it would have been confusing. Divide by what? Before you subtract? I mean, it's puzzling. So that was a necessary parentheses, but it wasn't a grouping. The point is, you do have to divide. This is a multiplication. This is simply a signed number. So, division's first, multiplication's second. So I would have said this is a negative 8 times 2 minus 14. There's not much of a way I think I want to jump from here to the negative 16 in my head. I think that would be a dangerous jump. Technically you can do it, but maybe a bit too dicey. So now I have a negative 16 and then a negative 14. That's what I do in practice, but what would you probably be told to do? Plus a negative 16. And this is where I think it's probably very reasonable to expect that as an intermediate step if you were showing a solution. This one, I would be inclined to go ahead and do that much, because now it's very clear I have what? 3 negative numbers that I'm adding together. So I'm going to get a negative at the end. I like doing these two together because I see a negative 30 there, and I have a negative 30 there, so you get negative 60 and you're done. That's a little better illustration of what I think you need to do in documentation. And that's what I need to see, what Larita needs to see in your notebook that you're getting checked off. You have to show some documentation for me. Okay? The more effort you put into that, the better the payoff. But don't let it get you into so much time that you can't finish a problem in a reasonable time. What would be a reasonable time to do that problem, beginning to end?
90 seconds.
I'd say 1 to 2 minutes. Now, if you spend 5 on it, you're going to be working slower than you should. You need to practice. And that doesn't say 5 minutes isn't a reasonable time. It's just you aren't going to have that kind of time. So, measure your time. If it's more than 2, you need to do more practice. Yes, Marisol? Second line.
You have negative 8 times 2 minus 14. And then on the bottom, you have negative 16 plus negative 14. How come it's plus and not times? Because you're just moving it over.
Wait a minute. I had a dot here. That's a multiplication. And I'm supposed to be doing multiplications first, right?
Yes.
And that's a subtraction, temporarily. Okay, so I do the multiplication first because they're together. Wouldn't that give me negative 16?
Yeah.
You don't like the plus negative 14?
And that's what I'm asking, like, why is it plus negative 14 instead of...
I'm simply saying anytime I see an a minus b, I rewrite it as a plus negative b. This is, the garbage here is all a, and this is minus b. So it's plus negative that. Just because you're replacing a subtraction by an addition. Now, again, if you had gone from here and just put a negative 14 here and say negative 16 and negative 14 is going to be negative 30, you'll get it right. But what we're trying to push is this equality here that we're replacing a subtraction problem with the addition of the additive inverse. This, I think, illustrates that better than if I just left this as negative 14. Kim?
So when you have more than one negative, doesn't it turn a positive?
If I have more than one negative, if I had 2 negatives multiplied together, it would be a positive. But this negative here is separated from that negative by a plus sign. It's when I multiply 2 negatives, I get a positive. When I add two negatives, I get a negative. And that's why it's important to me to rewrite this minus 14 as adding a negative 14. That didn't go well. You're tripping on something. You want to ask it again a different way?
Well,
Where are you seeing the two negatives?
is why it's different, because I do the mix of multiplication and the addition.
That's why we replace the subtraction with the addition of the negative to remind you that the multiplications now have to be done first. This was a multiplication. Now, if it would help to put a parenthesis around there to see those two multiply, maybe that's better for you if the period, it's a dot, but it looks like a period, isn't telling you multiply. And what we're just talking about here is the danger in this. Something just, for some reason, doesn't make sense to you momentarily, and then you sort of lose it all. So that can happen. Any other question here on this one? Okay, back center. (24). There's a trap here that you're supposed to avoid. So this is the water hazard, if you will. I need to get it in focus, and I'm having a heck of a time getting that. So there we go. There's 24. Oh, now I've got so much shadow on it. Come off there for a moment. I've got shadow blocking it. Just a minute. This is the question. Okay, now let's look at it. I don't want the answer there yet. Okay, go ahead. 25? No, I wanted 24. We're there. Okay. Now, comment. We had a statement I'm going to write on the board that tells me what has to be done here by knowing what shouldn't be done, if that makes any sense. I made this statement as we go to the board, that A minus B means A plus negative B. Here's another statement we made. If I have the square root of a product, what did we say it was? Not O-O. That's not the right answer. No, not necessarily. It could be, but that's not the point. What can I do? I can take the square root of A and multiply it by the square root of B. The statement I made was a verbal statement. The square root of a product is the product of the square roots. But this one is not true. This does not fly. This is an error. No way. Now back to problem 24. I can't take the square root of each part and add it together. I have to first do what?
Add them together.
Add 16 and 9 together, get 25, and the square root of 25 is 5. Enough there. Getting comfortable with it and not getting tripped up. And something will seem reasonable when it shouldn't. I mean, it may seem reasonable to take the square root of 16, the square root of 9, and say, hey, those are perfect squares. Sort of like the Pythagorean thing, and hey, I'm in business. And blow it. Because it seems reasonable. That's why you have to have, as we come back to the board here, this general kind of statement that you know these things as we come to the board, that these are comfortable to you, that you're familiar with them, and you know what they mean. Remember, there's another one related to this, and that is the square root of A over the square root of B is the same as the square root of A over B. So the square root of a quotient is the quotient of the square roots, as long as B is not 0, of course. Those general statements are there so that you can have them in your head. These are where you sort of store these in memory and come back to them whenever you need them. Let's come back center, and let's see if we can find. We're going to flip the page now. Yes?
Okay, the square root, the product of the square roots, if you were to do them separately, you'd get the same answer?
Okay, the question was, Jonathan, I'm going to go back to that board part where I have the square root of A times B, square root of A times square root of B. The question is, will I get the same answer if I do either way? Yes. I will. An illustration. Let's say I have the square root of 25 times the square root of 4. So the square root of 25 times the square root of 4. Well, we know that's 5 times 2. Agreed? And so that's going to be 10. Now, what happens if instead I multiply them first? I still get 10. That's what it's saying. Now, if I go back to problem 24, I must have moved. I did. My apologies. Okay. In problem 24, I had, back, turn the page. I don't even have to move the camera. I have a 16 and a 9, and they are added together rather than multiplied together. But if you remember the misleading cue, coming off there for a moment, the misleading cue is to what? See something that's misdirecting you. And you see the 16 and the 9, you say, I can take the square root of those, and I'm right there. What you note, or fail to note, it's an addition, not a multiplication. Dion.
Now, if it would have been like square root signs and 16, then another square root sign close together with the 9, then you can multiply.
Yes, I could. So what we're saying there, in the same way here I had 25 in this one, 4 in this one. If this had been the square root of 16 times the square root of 9, then yes, I would have said 4 times 3 is 12. Yes. Okay? Coming back. Now, as I said, I would like to go to the next page. Now, there's a point in the long division where you do 5-digit divisors just because they're there. And if you look at a problem like 68, it's sort of like, okay, yeah, you can. But the feeling is, do I really want to? Maybe it is a more natural reaction, something that looks that. Let's see, I don't have enough room yet to get the mess that's there. Okay, let's look at it. 68. This looks like one of those legal documents you're supposed to read. Now, I can tell you the answers. You can see it there. It's negative 23, and your reaction is, yeah. Okay. But so what? This is carrying things a bit to an extreme. But let's see what we have there. I'm going to bring this down a little bit tighter because right there in the first part, we get the infamous braces, brackets, parentheses. And your first inclination might be there's too much garbage. However, if I look at that, and I bent the page and shouldn't have. There we go. If I look at that, this innermost parentheses right here would be simplified, and this innermost would be simplified. Then this becomes a 7, this becomes a 3, and it would be a little bit easier. So let's try writing this mess and see if we can make it so it doesn't seem to blow you away. I think what I'm going to do is try that in this lower corner and hope I've got room. This is debatable, but you're going to have to help me out here. Let's see. I leave it up on the screen. I'll see what part I can. This is number 68. So I'm going to do that. And then I have a brace, or braces. Then I have a bracket. And then is it 13 minus 3? Yes. Okay, so 13 minus 3, parentheses, 1. No, wait a minute.
No, the 3 is not in parentheses. No, turn your parentheses around.
Turn my parentheses around. Okay, I have a 13. Minus 3, and here is the parentheses. Open parentheses is what I would say. So open parentheses, then a 1 plus 5? 1 plus 6, close parentheses? Then bracket, plus, open bracket, and what now? 18 minus,
Open parentheses, 5 minus 2, close parentheses, 2 squared, or 2, whatever. Squared. Yeah, 2 squared.
you said 2 squared. You mean quantity squared?
Yeah.
Okay, quantity squared, close bracket, Okay, the brace. Let's stop there for a moment. Let's go to the board with what we have. There's more there, but that's enough of a mess for the moment. Okay, so I'm looking at this. I guess I better rotate this way. I'm interested in this. It's a 7, and this is a 3. That much alone. Let me just walk off camera for a moment because I'm really short of space there. But now, if I go to the next step, just with this much, I'm going to leave this brace here. And now I have 13, and I have minus 3, which is really what?
10.
No, plus a negative 3, and it's multiplied by that 7, which I'll put in parentheses. Now, I could have said what? Negative 21. So instead of that, otherwise, instead of doing this, and that's a question, would it be any worse to say minus 21 right there? And this is still a bracket. I could put plus negative 21. My point being, either way, you should interpret it. What's intended here is, I think, to say plus negative 21, introduce this inside, and conceptually, good. Clutter, bad. I've cluttered the expression to a degree. Now, the next one, plus, open bracket. Now, I have an 18, and then it's plus negative 3 squared, so that's a 9. Close the bracket and brace. Because this 3 was in parentheses to the second, so I only squared the 3, which became 9, and I still had the minus outside. And if I'm blocking your view, then just look at the monitor. So again, where's the balance there? You have to be a little bit cautious you don't get too much clutter. Now, what's the next thing I would do? What? Well, this part here is going to be what? A negative 8, agreed? You had 13 plus a negative 21. So that's going to be a negative 8, and that's in the braces. I've replaced that whole bracket. Then plus, and now I have 18 minus 9, which is just 9. And so this mess, sorry, I don't need that. I can just do that with a brace now. So what does that come out as? 18 added to a negative 9. I'm going to have to rotate. Can't lean back far enough. That is an 18 minus 9. That's a 9. Now the 9 added to the negative 8 is just a 1. That whole mess came down to a 1. That wasn't all the problem. Okay, so I need to come back center. Let's go back to the document cam first. Okay, so I'm going to come back to the document cam and just move it. So I have 68, and now I'm supposed to do what? Subtract off a 6 times the square root of 25 minus 9. So leave that up there for a moment. So there was this at the tail end, and I have the square root of 25 minus 9, and then there's more. Okay. Now, continuing. What would I do here? I mean, technically, you could go ahead and say that's 25 plus a negative 9. I think I would just go here 16. If you're not getting confused, then go for it. So that's going to be minus 6 times the square root of 16. So when I take this as a product, technically it's plus a negative 6 times the square root of 16. But I think it's reasonable at that point to say in your next line, you would have minus 24, correct? Because that's negative 6 times 4, which becomes a negative 24. So now I have what? 1 minus the 24. I'm trying to think how I want to indicate that. Okay, 1 minus down here 24, which is equal to a negative 23. And let me walk off camera so that Jonathan can let that shine through. And of course, that was the answer given in this particular version of the text. Now, that's a mess, right? What are you battling as you look at that problem? I think overload. Overload, so many symbols, and the first reaction is, my God, where do I start? And there's a tendency to jump up and walk around the room, get something to drink, and do anything but that problem. Break it into pieces. Left part, right part. If it is so overwhelming, then practice the easier ones until you can reach the point where this doesn't panic you. Marisol, did you have a question, comment?
Yeah, I was wondering where you got the 16, and it says you minus the 25 and the 9, and I was doing the square root of 5, 25 is 5, the square root of 9 is 5.
Ah, let's go back to the board. Okay, but you were getting trapped because what Marisol's saying, she saw this and she got misled. Somebody misled you. The book. You saw, again, that perfect square, and that perfect square, and you said, I'll take the square root of 25. That's 5. The square root of 9 is 3. 5 minus 3. But back up to here. No. Slide just a little bit there. You were trying to do this one, and you can't. You've got to keep that in your head. So you get sucked into something because it looks right, when indeed it wasn't. Dion.
So on this particular problem, do we still have to, we don't have to follow the order given as far as the, the parentheses and the brackets are concerned, or can we do, like, how we break it down, how you just mentioned it?
Well, what I just did here, now I'm going to slide over here, just split and rotate so I can see, and come out just a little bit more for me on that, Jonathan. Now, what I did here, I took the left part by itself, and I did the innermost parentheses. So if I come back to the document cam, let's do that, because I think I can isolate there better to answer the question. Okay, I'm looking at 68, and I'm going to try bringing that down a little bit tighter, just this much. If I look at that part of it on 68, and I follow order of operations, the intent is to do what? Find an inner parentheses in this bracket, correct? So to that extent, I focused there. Then I said, well, I've got another one just like it, another set of brackets. And that's the case where I had this bracket, and I tried to simplify that. Then I stayed focused on that left part. Now you're saying, well, maybe I should have immediately gone here and addressed this 25 and the 9 that Marisol was just talking about and say, well, that's a 16. The square root of 16 is a 4, so 6 times 4, and do that all at the same time. That would be, I think, more in the spirit of left to right in order given and so on. If I look at the grouping as a priority, I don't think there's any question that I go to these brackets first, because that's the groupings. Now, the question, once you've done, as we come off there, Jonathan, if I'm dealing with the groupings, and then I have a radical kicking in there, where do you finally go to the radical? Do you try to get all those groupings done first? That was my argument. Group as far as I could. So if I go back to the board with camera 2, what I'm doing over here, just on this part that I just brought down, all I was doing was dealing with groups before I ever went to the radical. Remember, it's groups, radicals, exponents. I didn't have any exponents, so groups and radicals, so I did my groupings first. Then, when I got that simplified, did my radical, then did the multiplications, divisions, additions, and subtractions in order given. This problem is at the extreme border of, is it really necessary? Okay. And there aren't as many given in the assignment at this point. I think they're like every fourth one or something. Where in the earlier part, I'm doing like 1, 3, 5, 7, 9. Here it would be like 31, 35, 39. So you aren't doing so many of them. Let's come back center. Let's go a little bit further. Let's go down to the 70s. They were a good decade. 83. Now, each one is uniquely different, right? It's difficult to say, well, this is going to be always what I do. It's sort of like a puzzle each time. Hint, do the numerator first, do the denominator second. Now, this one is set up to mess you up. Let's look at the denominator. 9 minus 3 is going to be a 6, right? So I do the denominator, that's 6 squared. This gives you a 9 here, where I'm circling with the pen. So that's a negative 36. 36 minus 36? 0. Can you divide by 0? I'd be done and never touch the numerator.
What?
Okay, again, if I'm looking at this and I tend to do numerator and denominator, now which of those two might be the easier one to do? Maybe the bottom, because you have just a slightly greater complexity there. But I look at this and I get a 36 here. Then I get a negative 36.
Where do you get the 36?
Not, this is a 6. 9 minus 3 is 6 squared. No. This is a 36 for the first part. Then minus 4 times 9, which is your negative 36. That's 0. Anytime you get 0 in the denominator, quit the problem, say undefined, and go on. So let's go to 80.
Undefined is the N.
When you have, okay, you cannot divide by 0. There's no number that you can multiply by 0 to get something other than 0. So we say there's, now it may be the numerator 0, and if that's the case, we'd have 0 over 0, and that's called an indeterminate, because any number could be an answer. Let's see what we get in the numerator. That may clarify some of what was being said here. Back to the document cam. Okay, we have the brackets here, right? Now, do you feel it necessary to say 14 plus a negative 2 times 9? I hope not. 14 minus 18 is a minus 4, correct? So you have 3 times minus 4 here. That's negative 12. Now here you have a 5 minus 11, which is a negative 6. And you've got to remember, if you square the negative 6, you'll get positive 36. So that's not going to go to 0. So what did we say that we would have in this numerator? And what I probably should do, because that's a lot to keep in your head, and I think this might hold where I want it. I feel like I'm building little houses here, trying to keep things steady. Let's go to the sideboard now, because I've cluttered up the front too much. Okay. And I think you can see the fun you're going to have with this in a perverse sort of way. 83. So let me write it out. So I have a 3, then I have a bracket, then a 14 minus 2, open parentheses, 9, close parentheses, close bracket, then plus, and if somebody hears you reading one of these out loud saying brackets and open brackets, closed brackets, parentheses, braces, they may bring a brace in and walk you out. There's a 2. Then I have this, and that's going to be a 9 minus 3 quantity squared. Notice how we say quantity squared? Minus 4 times, open parentheses, 10 minus 1, close parentheses. Now we can go to the board. Now what? Not that board. This board. Thank you. So this is 6 squared, and this is minus 4 times 9. I'm just rewriting the denominator for a moment. That was 36. This is minus 36. Therefore, you're 0, and that's where you know you're in trouble. Now, top. This is 3 times 14 minus 18, which is going to be 3 times minus 4, which was negative 12. Now, Dion, I didn't carry through the whole part. You know, I'm sort of focused on that part. And then this was what? Plus, this is going to be a minus 6 squared, but that is plus 36. So negative 8 plus, negative 12 plus 36 is going to give you a what? That became 24 over 0 d in E. Does not exist. Undefined. Now the reason for that is this says take 0 into 24. There is no number I can multiply times 0 and get what? 24. It doesn't happen. We haven't defined anything that times 0 gives you 24. 0 times anything is 0. That's my 0 product rule. Not a property, okay? It is something we could prove using the properties. Robert, I'm delighted to see the eyes open. Yes, go ahead. I'll just let that go. Okay. I'm not even sure I want to repeat that. Okay, let's walk off camera here. Maybe it was better when the eyes were closed. Okay. Okay, now, is there anything else in this set that is, let's look at 82. And again, with what we've done, as we look at the document cam, we would, I would hope, maybe simplify each part separately. And can you, in your head, think of how you do that? Making it work? So if I were looking at your documentation, in some ways it would be nice to say, okay, write me a new expression each time. But I think I'd also be inclined to say, well, that's 6 times what? Negative 3, negative 18. 5 times negative 1, negative 6, that's negative 30. And then bring that right up above the brackets. You following me?
Yeah, like a pyramid.
Yes, building pyramids. Okay, I got a what? Okay, back to the sideboard. And again, the question here is sort of order out of chaos. Number 82. Let me write it first. Okay, 6. And if you are sitting there saying, this is getting awfully boring because I can do these with my eyes closed, hands tied behind my back, and never break a sweat, I'm very happy for you.
That's number 82. Not number 80.
Thank you. Okay, and I have 5 minus 6, close the bracket, minus 4 squared. Then, and by the way, one of the things I would check if I'm not getting answers that work or check correctly, make sure you wrote the problem down correctly. Because if you didn't, and you sit there, you can spend the next 3 hours trying to show that it works as we go to the sideboard and never come up with the answer. So make sure you first, you wrote the correct problem down. Secondly, make sure you're checking the right answer. I have been guilty of looking at the wrong answer on a different page, thinking I have the right answer, 3 hours later getting very upset because it's not checking, go and ask somebody and say, well, you're looking at the wrong answer. And you come back 3 hours later, you had the answer 3 hours ago and it was right. That's really frustrating. Okay, so here's, again, my argument is to do something like this.
So we're starting on the bottom.
Bottom or top, your choice. I made the choice this time. And this is negative 30. Okay, and I might do this just to make me feel better. And that's negative 18, negative 30, negative 48. Then I have a minus 16.
So you have 30.
And 40. Be careful. Both of them are negative.
No, negative.
So it's going to be negative.
32.
No.
No?
Okay, that's where you want to say.
Okay, there you go. That's clear.
Okay, now, that's maybe why you want to do it, okay? Negative 64.
Yeah, that's clear right there.
Okay. Now, down here, 10 minus 2 times the negative 3 squared. I'd be a little bit more cautious here because I see that being what? A negative inside. So I realize, well, that's 10 minus 2 times 9. That's 10 minus 18, which is negative 8. Okay, so now I have a negative 64. Jonathan, there you could, thank you for the tweaking. And so that's going to be 8. Now, I think that's reasonable documentation. Is that acceptable or not? Marisol, are you grumbling? Which would you prefer it? Written it out line after line?
Oh, no,
Can we do that so we get the hang of it?
Oh, well, you can grumble because you got it wrong. That's acceptable. But just, is this okay? I might be a little more efficient and a little bit easier to see. True?
Question?
Yeah, Dion.
So you said we can start like either way we want, top or bottom.
Yes.
But didn't you also say we start at the bottom when we find out that it can't be?
Yeah, well, that's the nice thing. If you start with the bottom and you get 0, you can stop. 50% effort. So if you want to, as a rule of thumb, Emily, start at the bottom so you can 50% of the time throw out the problem before you do any more work. But think of the practice you miss.
Think of the time you could say.
Okay, back to the problem in the book, please. Document can. Okay. There's a lot of problems in there. Hopefully, as you look at those and you work with them, you're not going to be too stressed. I'm hoping that is the case. As we come off there, I'm going to close down here because we're out of time. And so, Jonathan, we were...